Okay, we're going to do our first little section right here on water quality. Actually, it's our third section. Let me turn my slideshow on. Okay, first thing we're going to talk about is temperature. Wait, it's working slow. Or temperature. That's how, basically, we'd say it's about how hot or cold something is. And basically, what temperature is the molecules inside your an object. When it's warmed up, they start moving more, and then when it's cooler, they start to slow down. We all know, everybody likes to drink cold water. Cold water is good. We've already talked about how cold water has more oxygen and how hot water has more carbon dioxide. You know those things. We talked about them when we talked about oceans earlier. Now, dissolved oxygen, that's the level of oxygen that's present in water. Remember, you want a high dissolved oxygen means you got better water, and a low dissolved oxygen means you got bad water. Now, we all know this dissolved oxygen comes from the surface air and also from aquatic plants when they do photosynthesis. Now, pH might be something new. It tells us it's a number, and it's usually from 1 to 14. You see the scale right here. It tells us how acidic something is. Now, acids like vinegar, orange juice, battery acid, those are things that are very acidic, okay? They're usually the lower numbers from 1 to 5, okay? A base usually has a pH of 9 to 14. That's like your bleaches, your baking sodas. Fertilizers are also bases, okay? You don't want to have anything. Organisms can't survive on the type of water that has very acidic or very basic. We like to have in other organisms and plants and animals and people. We like water to be neutral around 6 or 7. That's what you really want. That's ideal. Now, turbidity is always one of my favorite words. Turbidity, I always think it kind of reminds me of the word turd, because the more that the water has turds in it, the less you want to drink it. Okay, that's common sense. We all want to drink clear water. We don't want to drink water with turds in it. Okay, so high turbidity means it's very dirty water. You probably had a lot of that when the hurricane came and all that water was running off everywhere. That's probably some very turbid water. You want it to be very clear. Now, when it's really turbid and really dark, that's when it blocks sunlight. And so when it blocks that sunlight, the plants that live in that water, they can't produce any food and they can't make oxygen. So there's no photosynthesis going on. And of course, that kills everything that's living in that water. And of course, we're talking about organisms that live in the water, the bioindicators. These are the organisms in an environment in which we're still talking about water, aquatic environments in this section, that we analyze them and study them. And if these species die, then we know that this environment, this water is really, really bad. Some examples are frogs. You see that little picture of a little frog right there? And some certain types of fish, a lot of bugs and insects, algae. Lichens are kind of a mixture hybrid animal. It's part moss, part fungus. Actually, I don't really an animal, more like plants. But when they die, oysters are also an example. We talk about oysters and that kind of stuff in the ocean section. Now, potability. Potability is how suitable is something is for drinking. We know things like water, it's suitable for drinking. Orange juice, coffee, Coca-Cola, Pepsi-Cola, Mountain Dew. Those are potable things. Now, we know things that are not potable. We don't drink motor oil. We don't drink battery acid. Okay? Those are things we don't drink because they're not potable. Potable water, and we want it to be cool, low temperature. We want it to be very low turbidity, which means there's no turds in it. It's clear. And it has lots of oxygen in it. Now, our next thing is nitrates and phosphates. I want you, when you see these words right here, nitrates and phosphates, you need to think of fertilizer. Yeah, that's that stuff that farmers put on their plants that make them grow. Put on the crops to let them grow a whole lot quicker. Makes them grow quicker and bigger. Now, what can happen is those chemicals that are in the fertilizers, they can contaminate the water that is surrounding the fields. So farmers, they have to kind of regulate how much fertilizer. If they put too much, it can get the water supply. Also, it burns the crops if they put too much on it. So what happens is the water washes off, it rains, it runs off, and it goes into like a pond or a nearby ditch or a lake or whatever's nearby, whatever water surface is nearby. And what can happen, it causes an abundance of algae to grow in those bodies of water. And I know y'all probably have seen ponds that have a bunch of green gut on top of it. Okay, we all know what sewage is. Sewage is, when we poop in the toilet, we flush it, or pee in the toilet, all that goes out into the sewage, okay? Luckily, we live in a country where our sewage water and our drinking water are not the same thing. In some third world countries, those people have the same. They drink and poop and cook out and wash their clothes all out of the same water. So be thankful that you live in America, okay? That's why uncontrolled sewage, it can contaminate water supplies. That's when like the hurricane came and knocked off some people's flooding and water supplies. They were worried about sewage getting into the water sources. Okay, this word is one you never heard of. It's called eutrophication. We were just talking a few minutes ago about how fertilizers can run off into a pond that's nearby a field, and it starts causing the algae to grow. I mean, just like fertilizer makes plants of farmers makes his grow faster, it also makes the aquatic plants grow faster. And you get this green gunness. And I know y'all have all probably seen that. Every time I drive around with my wife, I say, "Look at that, there's eutrophication going on." Of course, she wants to slap me all the time because I say that and act like a nerd. But that's another story. And what happens is the eutrophication, it blocks all the sunlight and kills all the fish and plants that live underneath it. Here's an example. The farmer, he puts his fertilizer, looks like little turds, don't it? Because technically, poop is a fertilizer. And the fertilizer gets on there, it rains. The fertilizer can go run off into a pond, nearby pond. It goes to the pond, it's got these little algae. Guess what? The algae starts to grow a little bit taller. And then the algae starts to form on the green algae starts to form on the top. Then guess what? No sunlight can get in. There's no oxygen being made. That fish, that poor little fish, he's going to die. Okay, and then also the algae ends up dying too because it can't get any sunlight because it's being blocked. Now, water hardness. This is the measure of the amount of calcium and magnesium salts that are in the water. This usually comes from the rock that is in the ground and in the aquifers that we talked about in an earlier section. Some signs of hard water spots are, of course, dishes on your dishwasher when you put them in the dishwasher or you wash them. If you wash your white clothes and you have like a light brownish stains on them, that's water hardness. Now, it can be treated with things called water softeners that people will put in on their little pump houses and stuff. If you drink hard water, it's not going to do anything to you. You won't get sick or die, anything like that. And that looks like it is the end. Y'all have a good one. I'll see y'all next time in Mr. Ellis class. I better not see y'all at the clubs now.